Good afternoon, everyone. This is Miss Dasher. I am sorry I was not able to be in class today as I am in a meeting, as I explained yesterday during class. We're going to be doing exactly what I described yesterday, which is taking notes based on this video lesson. So you're going to take notes just as if I were in class, so you should have out your notebook, graph paper, and of course a pen or a pencil to take these notes with. You are responsible for taking these notes, so nobody has the excuse of just sitting there and doing nothing. Today we're going to continue with lesson 3.1, the rectangular coordinate system. And in this lesson we're going to work with x and y intercepts, recognize equations of both horizontal and vertical lines, as well as lines that pass through the origin. And we're also going to be using something called the midpoint formula. So here we go. All right, let's begin today by starting at where we left off yesterday, which was with intercepts, a very important part of what we're doing today. So yesterday we were starting by talking about the x-intercept. So if you already took notes on this slide, you don't need to write them down, but pay attention as it's a very important concept we're going to be applying. Remember, the x-intercept is where our line touches the x-axis. Remember that x-axis is this horizontal axis that I'm highlighting in yellow. So when I want to find the x-intercept based on a graph, I can just see where does my line hit that x-axis, and in this particular picture, it hits right here where I'm darkening it in with red, which is at an x value of -4. So my x-intercept in this problem would be -4. Similarly, I can find my y-intercept. The y-intercept is where the line hits the y-axis. The y-axis being this vertical axis that runs through the origin. So similarly, to find my y-intercept, I see where my line touches, which I'm darkening in red once again. And in this case, it occurs at a y value of 4. So my y-intercept is when y is equal to +4. When we're working on this later on and I don't have a graph, you want to remember this very important note. To find the x-intercept, you let y equal 0. To find the y-intercept, I allow x to equal 0. And we're going to apply that on the upcoming slide. So it's very important that you have this written down in your notes. So take some time right now and write that down. If you need to, you guys can go ahead and hit the pause key for a second. Alright, here we go. Let's do some examples. What we're going to be doing in this problem is we're going to be finding both the x and the y-intercept, and then after we do that, we're going to graph the equation. So if you have your graph paper, it's a good time to take it out. I'm going to start with example 1, which says 2x plus 3y equals 12. So I'm going to graph this by making a table of values, but in that table of values, the only things that I'm going to be finding are my x and my y-intercept. So let's go ahead and do our table values. Notice I've already made a little table here in which I let x be 0 for finding my y-intercept, and I also let y be 0 to find my x-intercept. So let's go ahead and plug in those values and see what we get. So let's start off by looking at it when we have x equal to 0. So I'm going to take that 0 and I'm going to plug it in for x in my original equation. When I do that, I get 2 times 0 plus 3 times y is equal to 12. I'm going to show every step along the way. I'm guessing a lot of you can skip this next step and move on to the third step, but I really recommend to you that you take your time on these. 2 times 0 is 0, so now I have 0 plus 3y is 12. 0 plus 3y is just 3y. So I have the equation 3y equals 12, which means my y is 4. So I'll put that into my table. All right, let's find our other value when I've got a y value of 0. So I'm going to take a 0 and I'm going to plug it in for y. So let's go ahead and plug that in for y here. When I do that, I get 2x plus 3 times 0 is equal to 12. Simplifying, 2x plus 0 is 12. 2x plus 0 is just 2x. And when 2x equals 12, that means that x is equal to 6. So when y is 0, x is 6. Now remember, we're going to plot these points on our Cartesian coordinate plane system, remembering that this is really just the coordinate 0, 4. So I'm going to go to my graph and I'm going to plot the point 0, 4. And I'll make a dot right there. I'll also plot the point 6, 0. And I'm going to take my straight edge out, as you should, either your idea or a ruler, and connect those with a nice straight line. So I get this resulting line. Remember, lines should always have little arrows on the ends of them to represent that they go on and on forever. Now just to rehash really quickly, I want you to notice here that when I plotted the point 0, 4, it was this point right here. That served as our y-intercept. So as a reminder, to find your y-intercept, you let x be 0. On the other hand, my other point that I plotted over here, which was 6, 0, is where it crosses my x-axis. Therefore, 6, 0 is my x-intercept. Your x-intercept occurs when y equals 0. Alright, we're going to try another one now that involves a fraction. So the same directions, find the x and y intercepts, then we're going to graph it. So once again, I'm making a table here. Remember, when I let x be 0, that's to find my y-intercept. And when I let y be 0, that's when I'm finding my x-intercept. I'm not going to go as slow through this one. First things first, I'm going to take my 0 value for x and plug it in, and let's see what happens. I get 2/3 times 0 minus 3y equals 7. 2/3 times 0 is 0. So 0 minus 3y is 7, which just means negative 3y is equal to positive 7. When I divide by negative 3, I get an improper fraction. That's okay. It's negative 7/3. Similarly, let me go ahead and find my x-intercept by plugging in a 0 for y. When I do that, I get 2/3 times x minus 3 times 0 is equal to 7. 3 times 0 is just 0, so I've got 2/3 x minus 0 is 7, or just 2/3 x is equal to 7. Now right now I want to ask you, what don't you like about what's going on here? Most of you should recognize that there's a fraction in here. We don't like it. So let's clear it. We're going to clear it by multiplying by the LCD. Who's the LCD in this problem? Hopefully you're thinking in your head, or you said aloud 3. It's exactly right. We're going to multiply both sides of the equation by 3 to clear that fraction. So when I do that, my 3's will end up canceling on the left-hand side, and I'm left with 2x is equal to 7 times 3, which is 21. Now when I divide by 2, I once again get an improper fraction of 21/2. So let's go ahead and let's graph this. To graph 0, negative 7/3. Well, 0 is easy enough. That's starting at the origin, and now I'm going to go down 7/3. 7/3 is 2 1/3. So I'm going to go down 2 1/3 of a unit, and I'll mark it right there on my Cartesian coordinate plane. Alright, now let's go ahead and graph our y-intercept at 21/2, 0. 21/2 is an improper fraction. As a mixed number, that represents 10 1/2. So what am I going to do there? Well, right now my graph only goes up to 1, 2, 3, 4, 5, 6, 7. So I need to make a choice here. Either I'm going to go ahead and extend my graph, or I'm going to scale my axis. For today, I want us to choose to extend our graph. In person one day, we'll discuss what we're going to do if we're going to scale our graph. So let's go ahead and extend our graph. Alright, so I got out some more graph paper here. You'll notice I just replaced that point at negative 2 1/3. And now I got to go to 10 1/2. Well, this goes up to 10. I'm going to go a half of a unit farther. That's okay. and I'm going to mark it right there. So this was my 10 mark right here. This will be about 10 and a half. All right, now take out your straight edge and connect that with a nice straight line. I get the resulting red line, remember, with arrows on both sides as it continues on forever. All right, we're going to have another example that looks similar to what we were doing on the previous two, but you'll see really quick why it's not. All right, we're starting with example 3, no fractions here, so you're all breathing a sigh of relief. I have example 3, which is x plus 5y equals 0. Let's go ahead and start by plugging in a 0 for x. If I take a 0 and I plug it in for x, I get 0 plus 5y is equal to 0. All right, that's just 5y is 0. If I divide by 5, I just get y is 0. Nothing too interesting there. So, when x was 0, y was 0. Well, now let's plug in this y value of 0. So I'm going to plug a 0 in for y and solve for x. I get x plus 5 times 0 is 0. 5 times 0 is 0. So I get x plus 0 is 0. And x plus 0 is just x. So x is 0. If I were to only plot those points, where would I be going? Well, the first point is 0, 0. So I'd go to the origin and make a point. My second point is also 0, 0. So did I go anywhere different? Hopefully you're saying a resounding no. Can I draw a line using 2 points that are on top of each other? Absolutely not. So that's why I left another space in here. When both the x and the y-intercept are 0, we have to find another point. So pick any other point you want, either for your x or for your y value. My suggestion, keep it something small. Why don't we try it if we have an x value of 3? You don't have to choose 3, but I'm going to choose 3. It's a nice small number. It's positive. I put it in for my x. I could have just as easily put it in for my y. And now let's go ahead and solve. So I'm going to take 3 and I'm going to plug it in for my x in my equation. I get 3 plus 5y is 0. To solve for y, I subtract the 3, so I get 5y is equal to negative 3. I divide by 5 and I get y is negative 3/5. So I'm going to plot that point. When I plot that point, I'm going to go to 3, which is to the right 3, and then down 3/5. Well, 3/5 is a little bit more than half of a unit, so I'll put my purple point right about there. Now I can take a straight edge and I connect those 2 points with a line. Remember, 2 distinct points create a line. I get the resulting line. Notice it is straight. Remember, Miss Dasher is very particular. She will not be happy with curvy lines. There should be arrows on the end of it, and it should fill up a decent amount of graph space. Okay, now I want to talk about 2 very specific types of lines, which are horizontal and vertical lines. You need to understand the vocabulary with it to start. So first of all, let me talk to you about horizontal lines. A lot of times people get confused between the two of them. When I think of horizontal, I think of the horizon. Remember, the horizon is what you see when the sun is setting. So I always think about it as here's my sun, and there's that imaginary line right there where you see the sun setting over the earth. Notice it's a left-right line. So horizontal lines go left-right. In comparison to vertical lines, I always like to think about vertical lines like the ride at Six Flags, Vertical Velocity. Remember, vertical velocity are 2 different towers of roller coasters where you go up and down. So you go up and down, and that's the type of line that a vertical line is. It would not be very exciting if you went left and right. There would be no thrill in that. So that's how I keep in mind what those 2 different types of lines are. As far as understanding when you're going to get the graph of a horizontal or vertical line, you need to study this. It is critical. It will come up time and time again. If you have x equal to some number, it will always produce a vertical line. So notice there is no y. When there is no y in the original equation, your graph will look like a vertical line. On the other hand, when all you have is a y equal to a number, meaning there's no x in the original equation, that will be a horizontal line. So let's do two quick examples. These are really easy to graph once you study them. So let's start with example 1. X equal to -2. Which of these cases does it fall into? Is it a vertical line or a horizontal line? Hopefully you're noticing that it's an x equal to a number. Therefore, it's going to be a vertical line. So how do I graph this? I'm going to go on my x-axis to the value of -2. And let's make a dot. So I'm going on my x-axis to -2, and I'm making a dot. After that, I'm going to draw a vertical line through that point. So take out your straight edge and draw a vertical line, so a line that goes up and down through that point. The answer is that vertical green line that I've drawn in. All right, now let's check out example number 2. Now, example number 2 is as difficult as it can get for graphing vertical and horizontal lines. What I mean by that is you'll notice that there's a y and there's a number. The only thing we have to work to do here is get y by itself. And then it'll be back in this original form. Notice there's no x, and that's how I know it's going to be a special type of line. It's going to be a horizontal line. So how do I get that y by itself? What do I need to do in this problem? I'm going to add that 3 over. When I add the 3 over, I get 0 plus 3, which is 3. To graph this one, I'm going to go on my y-axis to 3 and make a dot. After that, I'm going to go ahead and draw my horizontal line through that yellow dot. So take out your straight edge now, and you want to draw a horizontal line through that point. Your resulting picture is shown. Make sure you study those tonight. The next topic we're going to talk about is something called the midpoint. Midpoint is a very important topic that we'll talk about in algebra, in geometry. It comes up in a number of different places. What is a midpoint? A midpoint divides a line segment connecting two endpoints in half. So in other words, the midpoint is the halfway point between two different points. So if we want to calculate the midpoint of two endpoints, what we do is we take the average of the x's and the average of the y's. For example, in this particular problem here, you'll notice that I have an endpoint at the coordinate 1, 1. I have another endpoint at the coordinate 4, 3. I want to find the coordinate of the midpoint, that point in the middle that cuts it in half. So to do that, I'll use the midpoint formula, which says I take the x-coordinate from the first point, add to it the x-coordinate of the second point, and divide it by 2. That will be the x-coordinate of my midpoint. Similarly, to find the y-coordinate of my midpoint, I'll take the y value from my first point, add it to the y value from my second point, and divide it by 2. Let's do some examples with this so you understand what this formula means. This definitely is another formula that you need to memorize. Okay, let's find the midpoint of the line segment who has endpoints 1, -6, and -8, -4. First of all, I'm just going to remind you of what the midpoint is based on that formula on the previous slide, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Remember, the midpoint is a point. It has an x and a y coordinate. All right, before we begin, I'm going to take one small step to help us out here. I'm just going to refer to this yellow underlined coordinate system as point 1, and I'll refer to the second pair as point 2. So, When I'm talking about 1, -6, remember your x value is the first one, and your y value is the second. Same idea with your second point. The -8 is your x coordinate, and your -4 is your y. So what I'm going to do here is I'm going to add together the x's. So I'm going to take the coordinate, the x coordinate from the first point, and add to it the x coordinate of the second point, which means the x coordinate of the first point was 1, the x coordinate of the second point was -8. So all I did right now is I took the x coordinate of both points and I added them together. Then you divide by 2, because what you're doing here is you're taking the average of the x's. That'll result in the middle x value. All right, to do the y is very similar. I'm going to go ahead and I'm going to take the y value from the first point and add it to the y value of the second point. So I get -6 plus -4 divided by 2. And now we're going to simplify. 1 plus -8 is -7. -6 plus -4 is -10. I cannot reduce -7/2, but -10 divided by 2 is -5. So the midpoint is -7/2, -5. I'm going to verify this to you. This is not a necessary step, but I want to show it to you so you understand that this really is the midpoint. Remember, that's the middle of it. So I'm going to switch out my graph paper, and I'm going to prove to you that it's the midpoint. All right, I'm going to go ahead. I'm going to graph my first point, which was 1, -6. And I'm going to graph my second point, which is -8, -4. And connect them with a nice line segment. Notice I said segment and not line. I was trying to find the midpoint, so I want to find the point that divides that in half. If I did all my calculations correctly, that should be at -7/2, -5. Remember, -7/2 is -3.5. And I'm going to go down 5 to get to my y coordinate, which is where I place that blue dot. And you can see just visually that that blue dot splits that segment into 2 equal parts. Therefore, we calculated the midpoint correctly. All right, last example for the day. Same idea. We're going to find the midpoint, but now we've got 2 ugly endpoints. All right, so to find the midpoint, what I'm going to do is I'm going to add my x's and divide by 2. So my x coordinates here in this problem were -1/3 and -1/2. So I'm going to do -1/3 plus -1/2 all over 2. All right, let's deal with our y's now. Remember, for your y's, you're going to add together your 2 y coordinates, which is 3/7 and 5/14. So 3/7 plus 5/14 all over 2. Right now I'm guessing you're becoming terrified because not only do you see one fraction, but you see 2 fractions in a numerator divided by another number. Just like we've done in the past, we're going to simplify our lives here. What we're going to do at this step is you're going to look at the denominators in this problem. Treat each coordinate separately. So first I'm going to look at the first half. What is the common denominator of 3 and 2? You should recognize that the common denominator of those 2 numbers is 6. So what I'm going to do is I'm going to multiply the top and the bottom, so the numerator and the denominator, by the LCD, which is 6. So I'm going to multiply every single thing by 6. This will help me to clear my fraction. So now we should be pretty good at this. When I clear, the 3 goes into 6 2 times. 2 times -1 is -2. 2 goes into 6 3 times. 3 times -1 is -3. On the bottom, 6 times 2 is 12. That's a little nicer looking. All right, let's do the same idea in our second half of our problem. Who is the least common denominator of 7 and 14? Once again, I'm hoping you're able to say 14 pretty quickly. I'm going to multiply everybody by 14. So when I do that, 7 goes into 14 2 times. 2 times 3 is 6. When I do 5 14ths times 14, those 14s cancel, and I'm just left with 5. On the bottom, 14 times 2 is 28. Now I can simplify easily. Negative 2 plus negative 3 is negative 5. 6 plus 5 is 11. Does negative 5/12 or 11/28 simplify? No. So your midpoint is the coordinate negative 5/12, 11/28. All right, depending on when you finish this video, I'm imagining you still have some time left in class. I'm expecting all of you to take out your textbooks, which you know you should be bringing with on a daily basis. It is not acceptable for you not to have your book with you. The sub will not be sending you to your lockers. You need to share with someone adjacent to you. This does not mean that you're talking throughout the entire time you're working on this. You are quietly working and sharing. You are working on pages 157 to 158, numbers 38 through 70 even. We will talk about these tomorrow during class. Whatever you do not finish in class is homework.